Players now have the ability to enter into our lottery contract through the enter method right here. After the contract gets some number of players who have entered into the lottery, the manager of the contract should then be able to call the pick winner function. The goal of this function is to randomly pick a winner out of the list of players. And the key word in here is randomly. So we want to look at the list of players that are in the players array and randomly pick one entry in there and say, hey, congratulations, you're the winner, you get some amount of money. This function is going to be a little bit more challenging than you might think to write, and let me tell you why. If we were using any other language besides Solidity, so let's say JavaScript, Ruby, Java, whatever it might be, to pick a winner, we might say just randomly pick a number, and then using that number, pick a random element or a random index out of our players array right here. However, with Solidity, we do not get access to a random number generator. There's no such thing as a random number generator with Solidity. So instead, we're going to kind of fake the random aspect of this. Now, one thing I want to be really clear on, there is no random generator. So the kind of code that you and I are going to write to randomly pick a winner is what we refer to as a pseudo random number generator. By pseudo random, that means that it's really not quite random and that our system for picking a winner can actually be theoretically gamed. In other words, people can kind of cheat on our lottery. So why are we making a lottery contract at all? Well, this is one of the big topics around Solidity. It is tough to do random number generators. And it turns out that a lot of contracts that people end up wanting to design sometimes require some aspect of randomness to them. So I just want to make it really clear in this contract that it is tough to truly randomly generate a number. All right, so let's talk about exactly how we are going to do it if it's supposedly so hard. So we're going to have a pseudo random generator. Again, that means that it's somewhat possible for outside people to influence the outcome of our random generator. We're going to take the current block difficulty. Remember, we spoke about difficulty a little bit ago when we spoke about how it takes some amount of time to process an actual transaction. That amount of time that it takes to pick or kind of solve a block or close out a block is referred to as the block difficulty. This is represented as an integer. So this is, in theory, a large number. We're also going to take the current time and the list of addresses of all the people who have entered into our lottery. So I put on here addresses of entrants. Technically, let's change the vocabulary here. It's really the addresses of players. We're going to take these three inputs right here and feed them into the SHA-3 algorithm. Remember how this SHA-3 hashing algorithm works. It takes in some arbitrary data and then it spits out a really big number in hexadecimal. We're going to take this really big hexadecimal number right here and then use that to pick our random winner. So what I want to make sure, again, is really clear here is that the current block difficulty, the current time, and the addresses of players to some degree is known ahead of time. Whenever someone wants to pick a winner, we kind of know what the current time is. Like if you and I send a transaction in to pick a winner in our contract, you and I could, in theory, have a reasonable idea as to what the current time will be when this function is executed. We also know ahead of time the address of the players, and we probably also know the current block difficulty. So if we know these three sources of what we are calling randomness, then it's really not truly random at all. So again, there's really no good idea of random number generation with Solidity contracts. And if possible, you want to try to design your contracts to not include the idea of randomness at all. There are some workarounds to this. So there's kind of a workaround or two, and I'm going to link these workarounds in the next video as a text lecture. However, these kind of workarounds for getting some aspect of randomness into your contract is a little bit more difficult. So in this contract that you and I are putting together for the purposes of learning, we're going to take this approach. But if you have a contract where you really truly need to get some random number, then you can check out that article that I'll link in the next lecture. Okay, so let's start writing up this function. Now, rather than putting this function or this random number logic directly into the pick winner function, I think that it would be kind of handy to maybe make like a little helper function that we can call at any time that will generate a random number. So back inside of Remix, let's make a little helper function. I'm going to call this thing random because its goal is to generate a random number. We're going to make this a private function because this is a great example of where we are making a private function that I don't really want anyone else to call. I don't really want anyone else to write this or call this function. It's really just for you and me for the purposes of the lottery contract. Next, I'm going to mark this as a view type. We are not modifying any state or any data in the contract. The only goal of this function is to return a random number. And so we will also say that this function returns some value, which in this case is going to be an unsigned int. Remember that an unsigned int without any number after it is an alias for uint256. So technically when we put uint right here, it is technically a uint256. Just a quick reminder. Now inside of here, we're going to take those three pieces of pseudo randomness. So we want our current block difficulty, the current time, and the addresses of our players. We're going to feed them into the SHA-3 algorithm. So first, we will reference the SHA-3 algorithm. So we can call the SHA-3 algorithm like so, by simply saying SHA-3, and then passing in the elements or the pieces of data that we want to have hashed. As a quick aside, I just want to mention that SHA-3 right here is a global variable or a global function. So we don't have to do any import statement, nothing like that. We can simply call SHA-3. You will also sometimes see, rather than a mention to SHA-3 right here, you might see kekgak256 like so. Recall that much earlier in the course, we mentioned that SHA-3 and this, however you pronounce this word right here, mean essentially the same thing. SHA-3 is the kekgak is a class of algorithm. SHA-3 is a particular instance of it. So kekgak256 and SHA-3 are the same thing. Then inside of here, we can start to pass in these sources of kind of pseudo randomness that you and I want to make use of. So we can say block.difficulty. Notice that we are again making use of a global variable right here. So the block variable is a global variable that we have access to at any given time. Difficulty will be a number that indicates how challenging it is going to be to seal or solve the current block. Next, we will pass in, the current time, which again is a global variable of now. And then we'll also pass in the array of players, which we can reference simply as players. All right, now inside the random function, we do have to make sure that we return an unsigned int. But as we just discussed, this is our hashing algorithm, and it returns a hash, so a hexadecimal number. But we're saying that we want to return an integer. So we can convert this hash right here to an integer by passing in the hash we just generated into a uint function like so. Uint. This will take this hash that we generate right here and turn it into an unsigned integer, which, as we've discussed many times, is essentially a number. And then the last thing we have to do is make sure we actually call it, or excuse me, return that value. So we'll say return and then the uint statement. All right, let's test this out and see how it's doing now. So back inside of my panel over here, I'm going to make sure that I have my JavaScript VM selected. I'm going to delete the existing contract that we've deployed for testing down here. And I'm going to create a new instance of the lottery contract. All right, so here's the new instance. Now the instant that we deploy this thing, you'll notice that we have no new button on here to actually call the random function. And that's because we marked this function as private. So whenever we mark a function as private, we get no ability to call that function directly. So just this one time, for the purposes of testing, you and I are going to change private right here to public instead, just so we can run this thing and test it and make sure that we get some reasonably random number. So I'm going to change private to public, as you see right here. I'll then kill the contract that we just created, and I will create a new instance by clicking create again. And now you'll see random appear. We can now click on random, and you'll see that we get this gigantic randomly, or at least pseudo-randomly generated number. And we can click it, and every time we click it, it appears to be a new random number. But again, remember, this is pseudo-random. It's not truly random, because we can ahead of time have a reasonable idea of what a block's difficulty might be. We can have a reasonable idea of what the current time is, and of course we can very easily always retrieve a list of players. So although it looks like it is a random number, ahead of time people can kind of figure out these variables, and trust me, if that's all it takes to get access to some money that's stored inside your contract, you have to assume that people might try to game this right here. All right, let's change public back over to private, and we'll leave it right there. So let's pause right now, and when we come back to the next video, we'll start finishing up our pick winner function. So quick break, and I'll see you in just a minute.